speaking on building AI agents with AWS Strands Agent SDK. Please join me in welcoming Deepak Benny.
Thank you. Hey, everyone. I know I'm the last person standing between you and the last set of goodies, so I'll try to keep it short. Be a quick show of hands while they are starting the presentation. How many of you here are running AI agent workloads in production? Okay, I see a few hands here and there. That's good. So my session, okay. Yeah, so I work at Nubinix Technologies. We are a group of technologists working on some interesting, challenging problems. In the past, I've been associated with Intuit. I was leading the development productivity org over there. And in the past, I was associated with the platform engineering team at Swiggy. And before that, I was part of the DevOps team at Ola. So that's a quick introduction about myself. Now, before jumping into the topic for today is using the Strands Agents SDK. But before jumping into all the AI agent stuff, I just want to create a baseline of our understanding of our AI system so far. Right? So over the last 7 years, we've seen a tremendous improvement in the AI ecosystem. And somewhere around 2019, we saw a paper coming out from Google, the transformer architecture. And based out of that, we see massive improvements in the LLM space. And specifically, OpenAI came up with a very good iterative model in which they trained large amount of data. And mostly, we've been interacting it with on a chat interface. So you give a prompt, and you get back a response. And over the period of next couple of years, the smart engineers at Google and Meta, they came up with a React framework or a React paper, reasoning and action. That led into the discovery or the invention of LLM plus tools, which is now what we call as function calling. Right? And that was also a breakthrough because now you can have custom functions added to your LLM which can perform actions for you. And that again led to multi-step reasoning, multi-agent workflows. And now we have frameworks available to build production-grade agents, which obviously includes security, observability, and governance architecture and built-in. So what is AI agents, right? I mean, specifically, if you take a look at the LLM, the ChatGPT LLM right now, it kind of performs almost everything that an agent can do. So if you specifically look at LLM, it's a large language model trained on a vast amount of data. And if you ask a specific question, it will answer based on the data that it generates or content that it generates. But if you ask an LLM, if you download an LLM model from Olama in your local, and if you ask it what is the time now, it will not be able to respond because it doesn't understand the current context. And that's where tools will come in handy. Now suddenly you can write a small function to calculate the date based on the system interface. You can integrate it with your LLM, and now it can answer what is the time now. Because whenever you ask a question, what is the time, it will invoke that specific tool to understand what is the time now. And then you now have memory, you have control. So combination of an LLM, tools, memory, and control forms an AI agent. So it can reason, it can plan, it can act, it can interact with API sources, infrastructure, multitude of things, right? It all depends on how much you can configure actions on these LLM agents. And now coming to Strands agents, there are a bunch of things that Strands agent supports by default. And one of that is Bedrock, using Bedrock as the first-class citizen. I think there was a slide which was missed here, but what it essentially says is the LLM tools, memory, and control. You see the plus signs in between, right? That's what Strands does. The plus signs over there, Strands will take care of integrating all of these things for you. When you have an LLM, how do you actually integrate a tool with an LLM, right? You write a function in your VS Code editor. You have an LLM sitting in your local laptop. But how do you actually integrate these two? That's where Strands come in. So if you use a Strands agent SDK, it can help integrate all your custom calling tools, custom calling memory, control. All of those can be integrated with the LLM. Now, okay, so then what is the LLM that you can integrate it with? That's where Amazon Bedrock comes in. Strands Agent SDK, by default, provides a bunch of integrations by default with the models available in Bedrock. So when you initialize a Strands Agent SDK, which is coming up in the next slide, you will be able to see how easy it is to initialize a simple agent using this SDK. And obviously, most of you might have seen the Bedrock interface. There are multiple LLM models which are currently supported in AWS Bedrock. So all of those agents are supported by default, or all of those LLMs are supported by default in Strands SDK. It can support single agent and multi-agent architecture. There's a direct guardrails integration support. So if you have seen or if you have explored AWS Bedrock, you will find that it have the guardrails integration, which is a quite important attribute in today's time, because when you build an AI agent and when you release it to the production, when you release it to the external world, there are all sorts of hacking and exploit attempts that can do, starting from prompt poisoning, overriding prompts. So AWS Bedrock Guardrail provides a support to mitigate all of these potential exploit impacts. And there is observability built in. You would want to know how many tokens are in use. You would want to have certain actions based on that data. For example, let's say you're using an OLite model or an LLM, and you would want to basically switch to a premium model for a certain duration of time based on certain observability metrics. All of those are supported in Strands Agent SDK. So this is how you initialize a Strands agent in your local system. It's as simple as installing a package and initializing the agent. So obviously now the question is, okay, where are we defining the various models, right? What is the configuration that we have to provide? So remember the last slide I mentioned that Bedrock is the first-class citizen when it comes to Strands Agents SDK. When you initialize agent in the line 2, what happens is there is behind the scenes, the Anthropic Cloud model gets initialized. And obviously, you have to pass in your AWS credentials in your local to get this working. But essentially, it uses that LLM to answer all of these questions. And of course, you can change all of these configurations by having some additional properties added into this initialization structure. And Strands Agents at this time supports Python and TypeScript. Those are the two variations of SDKs available right now. And to give you a bit of background about the SDK itself, it was first created by Amazon and then open sourced out to the world. So technically, it's a free and open source software which supports all these multi-agent, single-agent frameworks. So now we will dive deep into what is a single agent, what is a multiple agent, what does that mean in context of Strand. So a single agent is a very straightforward thing. Most of us have seen and used the single agent part. It's a basic LLM combined with a tool. A tool can be anything. It can be a simple function to check the weather. It can be a simple function to get the date. And the LLM, once integrated with the tool, when asked the relevant questions, will invoke the tool, get the data, returns it back to the user. This is what a simple single agent does. For multi-agent, it's a network of agents. Think about a planner assistant application, right? Where a single agent doesn't really suffice the requirements. You would need a flight booking agent whose responsibilities will be to talk to the flight booking app, its APIs. You talk to a hotel reservation agent. You have a currency conversion agent. All of these comprises of a multi-agent ecosystem. Now, I want to give you a basic walkthrough rather than going into superficial and multiple things. So we have few workloads running in production using using the AI agentic framework, right? So, and our use case is pretty simple. It's not a very complex use case. So we, like I said, I work at Nubinix Technologies, and we are a cloud consulting firm, and we work with various clients to understand their requirements. We figure out what is the issues they are facing, and we document all of those. And pretty much standard thing is you create a scope of work in terms of what are the issues documented, what are the deliverables, what are the commercials. So all of these you document in a scope of work, and then you share it with the customer. They'll sign it, they'll send it back, we sign it, we'll store it in our documentation. Now, the scope of work contains a lot of technical details which are required for our technical team, right? Because it will contain architecture details, implementation details. Now, we have our own native systems built in to store all of this information, to give RBAC access to these documents to our technical team members. But one of the challenges that we were facing was some of these confidential aspects, or the commercial aspects, are not relevant to the technical team. And we didn't, and so far we were sort of removing it manually. So we had our sales team, they used to remove all of these commercial details and confidential details from the document manually and used to upload into our system. And the specific team members who are implementing those details, they'll be able to look it up. They will be only seeing the technical details in the scope of work. So we wanted to take a stab at Strands agents to see how we can solve this problem using this particular framework. So what we did is, so there were a lot of iterations that we did. We did a single agent approach. Eventually we iterated it to a multi-agent approach, and eventually this is the approach that we have created, right? It's a three-step approach, right? You have an analyzer stage, you have a cleaner stage, you have a validator stage, each having its own purpose. And all of this was built using Strands Agent SDK. The first stage, it's an AI agent stage. What it does is it will load the Word document, right? And this particular AI agent is already configured with relevant prompts to identify the commercial aspects of the document. And what it returns is a JSON response, which will give the line numbers of where these specific commercial or confidential aspects are. Now it will pass that response to a second agent. And this is not an AI agent, it's pure code. What it does is it will redact the specifics, details related to the commercial aspects, which will then pass on the data to the third validator agent. What it does is it will basically iterate and identify if the relevant sections related to commercials and confidential information is correctly redacted from the system. And if it does, then well and good, that stage is passed. If it doesn't, it'll call the analyzer stage again, and the same cycle repeats. Now we have a max threshold for how many times this cycle should continue, but essentially this is what it does. Right? So there are multiple advantages with the way this was working that we could see. One thing was we could use different LLM agents in stage 1 and stage 3. So stage 1 was very specific. We wanted to specifically identify what are the line numbers responsible for the confidential, what are the line numbers which are attributed to the confidential information. So it was very specific. We wanted those exact line numbers and other metadata. Stage 2, like I said, doesn't even use an LLM because we want to ensure that whatever is the identified information we have to redact. So we actually wrote code to redact the information from the Word document. Stage 3 was relatively a cheaper LLM. It was, we were using Amazon Nova Lite. And this just have to understand the overall summary or overall context. So basic, with the summarization of the topic, it'll just return true or false, whether the validation have been completed or not, whether the confidential information have been completely redacted. And if the decision is yes, then the analyzer will not be called, sorry. If the decision is no, then the analyzer will be called. So few learnings that we had while building this multi-agent graph, and like I said, we've iterated multiple approaches in building this. One of the interesting things that we have seen is initially the previous node, if you look at it, oh, it's actually there in that slide itself. No, it's not there. Okay. So if initially it was just 2 stages, right? We had analyzer and validator in stage 1, and we had a cleaner in the stage 2. And the way we were working it out was the first stage was responsible for returning the specifics in terms of where is the confidential information. And it was also responsible for confirming whether all of the confidential information was completely removed. So that is how we initially configured it. But it was all going in a loop, infinite loop. We were not able to get the right responses. Sometimes it removes, sometimes it doesn't. But the moment we changed it to the 3-agent loop, we could basically get most of these right by just 2 iterations. Still, it required 2 iterations, but having that single responsibility principle, wherein for the first agent, we specifically said that the only responsibility is to return the JSON response with specific line numbers of where the confidential information is. And then for the last stage, we specifically gave the prompt which detailed that we would want to know if the pricing information is still present. So we had a lot of very detailed prompt on how to identify that. Once we did that, we were able to get very interesting results in the sense that we were able to get the right document with less iterations. And like I said, using specific LLMs for specific agents. For example, the stage 1, we used a relatively expensive model because we wanted to accurately track where those confidential information was. And the stage 3, we were able to do it with very lightweight LLMs because we were only interested in the summary and whether summary contains confidential information or not. So that part was very helpful in terms of reducing cost. And we were able to also log a lot of metrics. So this is another advantage of the Strands agents, because you will be able to log a lot of related metrics in terms of how many iterations, what is the input token, output token. Now most of those metrics are also available in your LangChain and LangGraph, all of those SDKs as well. But again, similar functionality is provided by Strands agent. Now, a couple of experimental features which is from Strands agent that we are working on now. If you look at the previous diagram that we had, this is a very fixed graph model in the sense that we specifically define stage 1, stage 2, and then stage 3. But then, what if we want more complex workflows? What if it is not deterministic in nature, right? And we had a few other use cases because within the document, we wanted to intercept some other data. So it doesn't really fit into a very deterministic workflows. So that is where we are now experimenting with. We are experimenting with an experimental feature of Strands agent. It's called steering actions. Now the advantage with this is you don't have to define a specific deterministic workflow. You can define certain set of tools, right? And you can combine it with an agent. And now the LLM itself will figure out what is the right tool to go to and what is the right workflow to take. Now, there are a lot of nuanced details into this. One thing, a basic example that I can share is if you create an agent today to implement a complex workflow, you might have to front load a lot of prompts, right? So the prompt itself will take up a huge token size in terms of input tokens. Now, one of the advantages of the steering action is Strands agent, obviously, you still have to upload all of these huge prompts based on your workflow, but the Strands agent will intelligently identify what is the relevant prompt for a specific workflow and will publish to LLM only those specific workflows. So there is a structure in which you can define these prompts using Strands agent, and Strands agents will iteratively reveal the prompts to LLM based on how the workflow is taking shape. So that is another area that we are working on with this particular feature. So the advantage is obviously you don't have to front load all of those prompts. Your token limit, you can still preserve lot of limits. And you will be able to get better results because now you are not using a deterministic workflow. Your workflow can vary based on the direction that LLM is choosing. And of course, there are a lot of edge cases where we need to handle what if the answers or the results that we are getting is not right. So all of those things are something that we need to take care of. But yeah, this is another feature that we are working on. Now, Strands Agent SDK in general allows deployment recipes to AWS Lambda, Fargate, EKS, EC2, all your normal deployment varieties. Bedrock Agent Core also supports Strands deployment. There is a Python TypeScript SDK, and that's what we are using. I'll show you in the next slide how it happens. But again, the implementation just involves invoking a few commands. Agent Core Launch is the SDK available in local to test all of this. So if once you install this Agent Core SDK, you just have to type in Agent Core Launch local. And if you point out where your Strands SDK code base is, it will take care of creating the Docker image, publishing it in your local. If you have Docker up and running, it will take care of creating a Docker container, running the Strands Agents SDK. So all of those are taken care by default built-in batteries. So yeah, so this was a very quick introduction about Strands. Strandsagents.com is the web page detailing all the quick start guides about Strand. The advantage is a production-first agent design, easy to deploy. We have tested it, so we know how easy it is compared to other LangChain, LangGraph models. Model flexibility without lock-in. Whatever models which are available in Bedrock is available in Strands. And simpler agent development. I just showed the initialization code, and to build on top of that is relatively very straightforward. Okay, thank you, everyone.